Bismillahirrahmanirrahim. So this is lecture number 9 of our course Advanced Computer Architecture. We have covered 3 chapters from the book that we are following. So today we will talk about memory system, particularly cache memory, and how the cache memory or the main memory is mapped to cache memory, and how the data is loaded from the cache memory to processor. So this is chapter number 4. We will discuss characteristics of cache memory. We will discuss the hierarchy of memory, and we will discuss the topic locality of reference. So first, let's go through the characteristics of cache memory or memory system. So these are few characteristics of the cache memory. Number 1 is location. By location, we mean whether the memory is internal or external to the system. In internal, we normally consider cache memory registers, and cache registers, they are internal to the processor. It means they are inside the processor chip. Main memory is external to the processor, but it's directly connected to the motherboard using PCI slot. So that's why main memory is considered internal to the system. External, these are like optical disk, magnetic disk, tapes. Now, if we consider HDD, magnetic disk, it's considered external memory, although it is inside the box of computer. But this was the the characterization at the time magnetic disks were introduced. And since it is not directly connected to the motherboard using PCI slot, so that's why it's considered external to the system or external memory. So internal, external, capacity, like how many bytes or how many words we can store in memory. These days we are normally using the term bytes. So words were used sometime like maybe 1 decade before, but now we are talking about bytes. Unit of transfer. So the unit of transfer means whether we can transfer data in terms of blocks or we can transfer data in terms of word. By block we mean like when we load data from HDD to RAM, it's in block. When we load data from RAM to cache, it's in block. And when we load data from cache to register, it's in word or byte. The access method, this is another characteristic. We normally use 4 types of access method to characterize or to categorize these different types of memory. One is sequential, direct, random, and associative. We will discuss these characteristics in detail. Performance, how do we measure the performance of memory? That is, we use 3 different parameters like access time, cycle time, transfer rate, and the physical type, like how the memory is made up. It may be semiconductor technology, it may be magnetic, it may be optical, it may be magneto-optical. Then physical characteristics, whether the memory is volatile and non-volatile, and maybe whether the memory is erasable and non-erasable. And of course, organization, the memory modules, like how different modules are connected. For example, in Core i9 we have different levels of caches, like L1 cache, L2 cache, L3 cache. then we have a RAM, and these caches, they are connected in a hierarchical structure, or maybe a ring structure. Different architecture, they use different structure. Some argue that ring structure is the most efficient. Some argue that hierarchical structure is the most efficient. So it depends on the architecture, whatever architecture you are following. So this is the further, like, we are going to discuss these details, these characteristics in detail. So memory, we talk about internal and external. And processor requires its own local memory, because we discussed that if we access data from RAM, it may be thousands of cycles to access RAM. One cycle may be 1 nanosecond, or maybe less than nanosecond, but 1,000 cycle is a lot of time in the context of processor. So processor needs memory that it can access within one cycle, because processor execute instruction in one cycle or two cycle or few cycle, depend on the instruction. Execution is just few cycle. So cache, so registers are required by the processor. Then cache is, but the point with registers are faster, but they are expensive, and we cannot have longer register because it will increase the access time for processor. So that's why we have short registers. Then we have another level, that is cache. Cache is another form of internal memory, which is faster than RAM but slower than register. And there are external memory. These are connected of peripheral storage devices, and these are accessible using I/O controller like HDD or CD drive, etc. Capacity, we normally express in terms of byte. Unit transfer, the unit of transfer is normally equal to the number of electrical lines into and out of memory module. These are few accessing units of data, different methods that we can access data. So one is sequential access. So here the memory is organized into units of data called records, and access must be made in a specific linear sequence. Access time is variable. Example are tape drives. Like in tape drive, it depends on where the head is located on the tape drive. For example, like a cassette player. So you have a cassette, and let's say it has 10 songs, and you are, let's say, in the middle. So when you put it in the tape, like when you want to play music, so you put inside the cassette player and the song start, let's say song number 5 start. So if you want to access song number 1, you have to rewind, you have to go back. And that going back depends how fast the cassette is, or the tape drive is rotated. So access time is not constant. Access time for song number 5 is immediate, like within few seconds. And the access time of song number 1 depends on how quickly you can locate the position of song number 1. Similarly, the access time of song number 10 is different, because you are at song number 5 and you have to go forward to access song number 10. So the access is actually a linear sequence, and in order to go forward and backward, you need to go through all the blocks of the data, all the records in the data. Like going to song number 10 and you are at song number 5, so you have to go through song number 6, 7, 8, 9 until you reach to song number 10. So that's sequential access. Tape drives, normally we use tape drives for backup purposes these days. These tape drives are not commonly used these days. The other method is direct access, and it involves a shared read-write mechanism. Individual blocks or records have a unique address based on physical location. Again, access time is variable. Examples are magnetic disk. So in magnetic disk or HDD drives, we have a magnetic circular tape, and the data is stored in sectors and in blocks. So these blocks, they are accessed by a shared read-write mechanism. There is a head that can read and write data, and these blocks are assigned physical addresses. And access time is variable because, let's say, if you are at position block number, let's say 10, the head is at block number 10 and you want to go through block number 15, so you will start from block number 10 and you will go through block number 11, 12, 13 up to 15. You are not starting from block number 1. So the access time is direct. Direct means wherever the head is located, but the access time is variable because maybe your head is on the block you are accessing, or maybe it's far away, and that far away depends on how quickly you are rotating the plate. So it's different than random access, because in random access the access time is constant, but here the access is random, like you can randomly access any location, but the access time is not constant. The access time is variable. The next we have random access. So in random access, each addressable location in memory has a unique physically wired in addressing mechanism. So keep in your mind RAM, random access memory. So all locations, they have a physically wired addressing mechanism, like they are assigned physical numbers, and the time to access a given location is independent of the sequence of prior accesses and is constant. So if you have 1000 locations, these 1000 can be accessed within a constant time. It doesn't depend where your head is previously located. Any location can be selected at random and directly addressed and accessed. Main memory and some cache systems are random access. Then we have associative. So associative is actually very particular to cache. In cache, we will discuss 3 different types of mapping. One is direct mapping, one is associative mapping, and one is set associative mapping. And the current technology, they are using set associative mapping. So that's associative. Here a word is retrieved based on a portion of its contents rather than its address. So like we will discuss this in detail, so just keep in mind cache, but we will come back to this mapping mechanism. So each location has its own addressing mechanism, and retrieval time is constant, independent of location or prior access pattern. Cache memories may employ associative access. So we will discuss associative in detail. These 3 important performance parameters are used. So one is access time, one is memory cycle time, one is transfer rate. So for random access memory, the latency is the time it takes to perform a read or write operation. For non-random access memory, it's the time it takes to position the read-write mechanism at the desired location. Memory cycle time is the access time, so latency, plus any additional time required before second access can commence. Additional time may be required for transfer to die out on signal lines or to regenerate data if they are read destructively. Again, these characteristics are specific to RAM. Concern with the system bus, not the processor. And transfer rate is the rate at which data can be transferred into or out of a memory unit. For RAM, it's equal to 1 divided by cycle time. Now, memory memory types, I think. So the most common forms are semiconductor memory like RAM and cache and some ROM, magnetic surface memory like the one we are using in HDD, and optical like the one we commonly see in CD and DVD. And there are some types of magneto-optical, and several physical characteristics like volatile. Volatile means that the data is lost when the electricity or electrical power is switched off. Non-volatile means that the data is stored there. You can keep it for infinite amount of time, like the data we store in HDD. Magnetic surface memories are non-volatile. Semiconductor memory may be either volatile, may be non-volatile. And there is another characteristic, non-erasable. It means that you cannot change the data inside the storage unit except destroying the storage unit. Semiconductor memory of this type is known as ROM. For random access memory, the organization is a key design issue. So for the RAM, it depends on how the blocks are organized. So memory hierarchy, I mean this design, like how much you should use register, how much should be the size of cache, how much should be the size of RAM, and how much should be the size of the HDD. So we use three different questions like how much, how fast, how expensive, and it's a trade-off amongst the capacity, access time, and cost. So faster access time means greater cost per bit. Like registers, they have faster access time but they are very expensive per bit. Greater capacity, smaller cost per bit. Like HDD, you can get 1 TB or 10 TB easily, but it's slow. The capacity is high but it's slow, and its cost is low. Greater capacity, so slower access time. So the way out of memory dilemma is not to rely on a single memory component or technology, but to imply a memory hierarchy. So this is what we call memory wall, and we need to employ memory hierarchy. So this is this memory hierarchy. We have registers, cache, main memory, and normally these are inboard memory, and magnetic disk, CD drive, DVD drive, Blu-ray, these are outboard storage, and magnetic tape, these are offline storage. So in this pyramid, the top pyramid, this is faster access time but expensive, and the lower part, it means slow access time and it's cheap. These are some links that you can watch to understand. Now, the last topic that I want to touch is this locality of reference. Locality of reference is an important concept to understand the memory hierarchy. So this is an important fundamental observation come from the property of programs. The most important program property that we regularly exploit is locality of references. It means that programs tend to reuse data and instruction they have used recently, which we also call 90-10 rule. So it means that a program spends 90% of its time in 10% of its code. Like if you write 100 lines of code, only 10 lines of code are executed 90% of the time. And an application of locality is that we can predict with reasonable accuracy what instructions and data a program will use in the near future based on its accesses in the recent past. So we have two types of locality, temporal locality and spatial locality. So spatial locality means they are close together, and temporal locality means they are accessed frequently. So let's say this is a file, some lines of code, and these instructions, they are closer together, like in the for loop or a function that is called frequently. and the other instructions, they are not executed. So this is spatial locality, and temporal locality means some instructions are executed for some sequence time. For example, in for loop we have few instructions, let's say 10 instructions. They are executed one time, and then second time, and then third time. So the 10 instructions, they are spatial they have spatial locality amongst each other. And the for loop, like let's say you have 100 lines, 100 for loops, so these for loop, they show temporal locality. So spatial locality means reference to data near X likely. This is data locality. So this is the X axis shows the time, and the Y axis shows data, stack, and code. So we can have we can demonstrate spatial locality and temporal locality. So like let's say if we look to this middle line in the code, so this demonstrates that these pink lines, they are closer together and they are accessed in this sequence. Similarly for the stack, it demonstrates some instructions, they are spatial locality, and like the one that are very close, they have spatial locality, but the one over the time, it's temporal locality. And here is this link that you can watch to understand temporal locality and spatial locality.